In this video, I'm going to show you how to write the solution of or the solutions of this system of four linear equations in parametric vector form if the case turns out to be so. So first, as usual, we will write this augmented matrix and then we shall row reduce it, okay? And after that, we are going to work with this row reduced echelon form for this system of linear equations. And now we have these two pivot positions in the first two columns, meaning that this column, the first one, and this second column, these two are our pivot columns, right? And since these two are the pivot columns, these become our basic variables, right? And these two are the basic variables, and x3 and x4 are what? They are the free variables, okay? So now we are going to write the system corresponding to this row reduced augmented form. So for from the first row we get this equation, okay? And when from the second row we get this equation, okay? So now what I'm going to do is that I'm going to erase this portion, and because now we are going to be working with these two, finally write our solution. Before we go ahead, we have noted from these two rows that this system is going to have infinitely many solutions. So now we are going to solve the basic variables in terms of the free variables. So let's do that. So one basic variable is x1. So there we get negative negative 3, and then this negative sign will change to positive, and then we get what here? Negative x4. So this is x1 in terms of the free variables, and then we shall also write the x2 in terms of the free variables. So when we are solving this equation, what do we get? 2 minus 5 x3 and then minus x4, okay? So this is what we have here. That is, we wrote our basic variables in terms of free variables, and now remember this, that we are trying to solve for the column x1, x2, x3, x4. So here I wrote that column matrix for you. So when we are solving these for x1, x2, x3, x4, so remember this. Now we are going to write everything in terms of the free variables, because we can, saying it in simple words, we can assign the free variables values freely. So this is what it turns out to be. So when we go further, notice this, that we can write these as, so now that we have only two variables, x3 and x4 here, what we will do is, let's just do a little alignment here for sake of clarity. So we did this, no constant in here before, so I wrote a 0, no x4 term, so I just wrote the coefficient as 0, just to help us write it down further. And here there is no x3 term, so I wrote this for you here. And then what will happen? We have this. So first we will write our constant terms. So we got negative 3, 2, 0 and 0 and 0. Okay, here we go. And then we are going to write the coefficient of x3. So what we will get is, or what we will have is, that we will have from here, see, we have 1, then we have negative 5, then here we have 1 again, and then here we have 0. So we wrote this down, right? And then for this portion we got we are writing the writing the coefficient of x4. So from here we get negative 3, then we get negative 1, and then we have a 0, and then for the fourth place here we have 1. Okay, so what we got is that the entire solution set here, okay, is expressed in terms of the free variables x3 and x4, and now you can freely assign them real number values and write the different solutions for the solution set of the given system. Okay.